Hello everyone, I'm Gaurav Singh, a first year student in Chemical Engineering Department, and I'm going to walk you through my project for the Merge Conflict Hackathon by MDGs based in IIT Roorkee. And my project is around federated learning model. I would like to first run you through my code and explain federated learning alongside it so that it all connects. First of all, in federated learning, I'd like to maintain the data security, which is my most important thing here in federated learning. What's happening is that I have a host setup and it will be sending weights initially to each model, to each worker, and then the worker will train on those specific weights and calculate the gradient. The data will be trained on an individual client around 10 times, which can be changed by me, and it will send the gradients after training to the host, and the host will be calculating the federated gradient at each step, at each epoch, and it will be updating its accuracy with this. I have used sockets to manage the networks over different laptops. However, I'll be showing you the demo on my single laptop so that it's really reliable. To run this on different laptops, you'll have to change the IP address. I've used it for the local host. And after connecting it, the host will be printing host is ready. It will be also taking the number of participants, which I'll be using too. I specifically called a ML model, which was around brain tumor classification, not classification, but to classify whether a patient has a brain tumor or not based on its MRI scans of brain. And I'd like to show you this. I have first linked the directory. If you are running this on your laptop, you have to change the directory. And if it is not the same, the list directory, the specific function of images, you will have to also modify that. And it's actually training on a total of 300 images. Like my client one is training on first 150 images, and client two is training on the latter 150 images. Like of the images which have cancer, the first 150 images which have cancer are being trained on client one, and the latter 150 images which have cancer are being trained on client two. And the same is for the images which don't have cancer, and I'm shuffling them. And for training, I'm using a total of 100 images, 50 with cancer and 50 with not cancer, and that it will have a total of 10 epochs, and it will be calculating the data within this 10 times. I've used federated average particularly so that if let's just suppose my clients are specifically hospitals, if one hospital have a data set of 1,000 patients and other have a data set of 200 patients, the 1,000 patients will be more accurate, as after each round of training its own dataset, it will be more reliable as it has more dataset, right? The ML model that is being trained on it will be more better compared to the 200 one, because the 200 one will more likely try to fit on its own dataset. However, my client one, like the another hospital which has 10,000, sorry, not 10, but 1,000 datasets, it will be more efficient, to be said honest, on a global dataset. Like if they encounter a random image, the 1,000 dataset model will be more better. To make sure we're on the same ground, my client one and client two, or both the hospitals have the same ML model on them, which I'd like to show you the code. It's basically in the train step, and I'm calling the sigmoid function as I'm calculating the probability. It's a master IP, and I'm calculating the initial accuracy using the binary function. The initial accuracy, the initial probability will always be 50%. So it will completely be a 50% of yes images and 50% for no images, and thus the initial accuracy will stay at 50% always. And the final accuracy will change each time. And I'm also plotting the accuracy after each epoch, so there will be a graph that I can get to see how the accuracy is changing over each epoch. Now I'll run you through the code. Terminal. I'll just take three new terminals and want so that it's all clear. Python host.py. I'll enter this. The number of participants pooling is, it's basically asking for the number of clients that I have, and for my particular model I have taken two, so I'll enter two. Now the host is ready. It has created a local server. Now I'll run another file which is Python, and it's client1.py. Now the client one is connected and the images are being loaded from the zip file. The I have to also explain how I got the images. The images are basically imported from the Kaggle database for brain tumor scans of MRI scans of brain tumor, basically, my bad. And I have used set blocking as well and turned it true. I'll just show you that. Set blocking, I have turned that true so that it won't move further before it actually gets an output. Set blocking, just a second. not my host Python. Yeah, I've turned the set blocking to true. It's by convention it's true, but I'm just specifying it that it's true. I also tried it with false, but that gave me some errors. But basically, it will wait at a worker until it has completed sending files before going to the second worker for files. So if I now get Python worker 2, it's basically client 2, and enter this. The client 2 is also connected and its image is being loaded. I've got the graphs that I will show later. But initially, there were a total test images of 100, as I said earlier. It matched a total of 85 images. Initial accuracy was 50%, final was 85%. That's great, in my opinion. Now I'll show you the second. Second had an accuracy of 84%. I can increase the accuracy in one way by not adding the noise. I'll not make the same mistake and show you my client. It's actually turning the noise so that host which has an update of global weights doesn't in any way retrace what my initial data was, as it's possible under recent research papers that I stumbled upon. So I'm adding a bit of noise so that it can be particularly traced back, at least easily though. Now I'll show you the graphs of for accuracy. I've got to open initially. For the first one of the model, it trained like this. Initially, it was 50% until went to round one, and then it just increased, decreased, it increased again, and lastly stumbled upon around 85 or 84%. In my opinion, it's again great compared to when it was on a single model. And that's everything that it was about my project. It's a code. I've used matplotlib to show the graphs. I've used a lot of sockets and its functions to send all. And a great thing that I've used that I would like to emphasize on is I'm first sending it the header. You can see this as it's receiving. I'm not on the host, okay? So it's actually receiving the header. It's basically what header is telling is what what to expect, the size of the file that you'll have to expect, and then it will be unpacking. What I'm unpacking is basically it's now it actually received a byte stream of bytes. So it now have to unpack this, and I have created a empty byte array, and it's going to extend this, and I'm using a loop of which will receive the bytes in the length of either 4096 or size minus length of data. I'll explain this as it's really interesting for me to explain this minute detail. But the 4096 byte that you see, let's just suppose it's a 4097 length. It will firstly collect the 4096 one, and then it will use the minimum, which is one, as all the one was remaining. So it can call 4096 or it will throw an error. Just a side note, if you are using multiple laptops, kindly change the wait, I'll have to first again find it. Yeah, master IP. For my laptop, it was 10.40.160.69 if I remember. And you will just have to open the command prompt. I'll just walk you through it again. And try type IP config. You'll have to use the IPv4 address, and it is for me because I'm just using a specific function here which will be using the IPv4, which is AF underscore INET under sockets. Thank you for your time and hope you liked my project. Thank you.